We are starting now with the core of this case, cleaning up messy data, and one of the major problems is clearly stringified and nested JSON data in some columns. And to handle this, we import the JSON module and also the AST or AST module. And actually AST stands for Abstract Syntax Trees, and we will see in a few minutes, how this can be helpful. And we've already seen that we have JSON data in the columns belongs to collection, genre, production countries, production companies, and spoken languages. So we save those in the list JSON columns. And maybe later on we can automate some cleaning steps. And now again, let's have a look at one element in the belongs to collection column. So this was originally JSON data, and we have here a dictionary with key value pairs. And actually the dictionary itself is a string. And inside we also have strings like ID, name, or poster path. And to distinguish strings, pandas actually created double quotes for the dictionary and single quotes for the keys and also for some values here in the dictionary. And now let's create a toy example for this. So we create the Stringified dictionary JSON one. And here we have single quotes inside the dictionary, and the dictionary itself has double quotes. And actually the JSON module provides the method loads. So let's have a look here. And with this, we can, for instance, deserialize the stringified JSON data into a Python object. And now let's simply try to pass JSON1 to the JSON.loads method. And here we get a JSON decode error. And it says that JSON was expecting property name enclosed in double quotes. So JSON.loads expected to have a dog and cat in double quotes, and the whole dictionary here in single quotes. That's a valid JSON string. And more general, JSON data is written as the name or key value pairs, and the keys must be strings, and the values must be one of the following data types: the string, number, object, array, boolean, or null. To sum up, this is not a valid JSON, as we require double quotes here inside. And now let's have a look at a valid example. So we have JSON2, and here we have dog and cat with double quotes, and for the whole dictionary we have a single quote or single quotes. So let's save JSON2, and let's pass the JSON2 to JSON.loads, and here it works. So now here we have successfully converted the stringified JSON data into a dictionary. And actually, before we can do the very same for JSON1, we have to replace single quotes with double quotes. So now this is a valid JSON, and now again we can pass this to JSON.loads, and now it works. And now let's go back to our movies data set, and for instance we have the column genre, and here we could apply to each and every element in the genre column the following lambda function. So first of all, in each and every element X, we replace single quotes with double quotes, and then we apply JSON.loads. So let's run the cell here. So this is the total genre column, and now even more important, let's have a look at one single element if this is still a string, and obviously we have successfully converted the stringified JSON into a list. However, there's a better way how to do it, and where we can save one step. So here above, first of all, we had to replace single by double quotes, and then we used the JSON.loads. And actually replacing characters in strings can always be problematic. And therefore there is a better solution, and we can use ast.literal eval. And let's have a look here inside. And in easy words, the literal eval evaluates a Python string and tries to find the real or more appropriate data type or data structure in this string. And that's exactly what we want here. So first of all, let's pass JSON1, and we get here the dictionary, and also this works for JSON2. So it doesn't matter if we have double quotes or single quotes. And therefore we can also apply ast.literal eval on each and every element in the genre column. And let's have a look at the very first element. And also here we have successfully converted the stringified JSON data into a list. And now we can actually override the genre column. And actually the same we can also try for all JSON columns. So we select the JSON columns and try to apply the ast.literal eval. And let's have a look if it works. However, here we get a value error, and it says that we have the value 0 somewhere in the belongs to collection column. So there might be some other problems in the other columns, like mixed data types. And last but not least, we can also double check the behavior here by passing the integer 0 to literal eval. And here we get the very same value error. So we have here not a string, we have just the integer 0. And this is not allowed for this method here. So we need to find a more general way how to handle the stringified JSON data in other columns. And that's exactly what we will do in the next lecture. So hope to see you there. Bye. Welcome to part 2. And first of all, we import the NumPy as well. And in the last lecture, we have seen that we have mixed data types in other JSON columns, like the belongs to collection column. And obviously an integer in this column doesn't really make sense, as we would expect a stringified JSON or dictionary with information on the collection, if any. And the problem is that literal eval drops an error if we pass objects other than strings. And therefore, we should make sure that we only apply literal eval on strings. So we could create a lambda function with an if-elif statement. And in this conditional statement, we have to check for each and every element whether the element is a string or not. And we can do this with the built-in function isInstance. So here we can check for each and every element in the belongs to collection column whether the element is an instance of the class string or not. And this works well. So the first element is a string, then the second element is a missing value, so this is not a string, and so on. And now we can apply the following lambda function to the belongs to collection column. So we check for each and every element whether the element is an instance of the class string, and if this is the case, then we apply ast.literal eval. And if this is not the case, then the element will be converted to a missing value with np.nan. So let's run the cell here and let's override the belongs to collection column. And here we are. So let's check, for instance, the very first element. And this is a dictionary here. Next, we can do the very same also for the column spoken languages. And also here we have lists with dictionaries. And also here we apply the same lambda function to all elements. So we have the conditional statement. And if the element is a string, then we use literal eval, and otherwise we convert it into a missing value. And the same we can also do for the columns production countries. So we override it, and production companies. So let's have a final look at df. And of course, at a first glance, we cannot see the difference. But actually now we successfully handled these stringified JSON columns. And still we have nested data in these columns. But instead of having strings or stringified JSONs, we have lists and dictionaries. All right, thanks for watching, and see you also in the next lecture. Bye.